We're talking about systems of equations, and we want to graph and solve systems of linear equations in two variables. Use algebraic methods to solve linear systems, and use linear systems to model and solve real-life problems. So in this case, a system of equations is two or more equations with the same variables. So in this case, when we're talking about the same variables, we usually are talking about x and y if we're graphing, and then sometimes we come into a system where we write different variables to represent different situations. To solve a system of equations, you want to find the ordered pair that satisfies all of the equations. In other words, the point of intersection. Okay, so that's what we're looking for. So we have these notes here, and we have a couple different systems that we could look at. So an inconsistent system has no solution. And when we're thinking about this, we're thinking about parallel lines. So that's what these are. These are parallel lines. And these are parallel lines because they have the same slope. The slope of this line is 1/2, and the slope of this line is 1/2 as well. When we're talking about consistent dependent, has infinite number of solutions. Basically, we're talking about the same line or overlapping. And the last one we have is consistent independent, has exactly one solution, and we can see that solution is right there, and these are intersecting lines. So if we look at the next example, or the next box here, what do you notice about the slope? Well, for this one, the slope is the same, so it should have the same slope. And then the y-intercept, well, if we look at this one, the y-intercept here is -1, and the y-intercept up here is 2. So if we're looking at parallel lines that are inconsistent, meaning not the same, they're going to have a different y-intercept. Same thing, if we talk about overlapping lines, what do you notice about the slope? Well, the slopes are the same because they're the same line. And what do you know about the y-intercept? The y-intercept is also the same because, again, they are the same line. And for intersecting lines, the slopes have to be different. So if we have intersecting lines that intersect at just one point, their slopes cannot be the same. And usually, but not always, the y-intercept is different. Sometimes the y-intercept could be the intersecting point. So that's what they look like graphically. If we're looking at inconsistent, they're parallel, they never touch, there's no solution. Consistent dependent, have the same slope, same y-intercept, they are the same line, so they have infinite solutions. And if we're looking at consistent independent, that means that there's one intersecting point for the solution there. That's what it looks like graphically. Now if we're looking at it algebraically, I'm going to use substitution to solve these because they're both equal to y, so we can use a transitive property, and we can set 2x minus 4, and we can set that equal to 2x plus 3. And we go ahead and solve that. The first thing I want to do is I want to subtract 2x from both sides. And then we get -4 is equal to 3. And at this point, we should start to notice something is wrong. -4 cannot equal 3, but we can continue to solve. So we add 4 to both sides, and then we get 0 is equal to 7. Can 0 ever be equal to 7? No. So we could have noticed it all the way back here. But if we're going through to solve and we get 0 is equal to some number, that will never happen. So that means no solution. The next one we can look at is 2x minus y equals 2x minus 4 and y equals 2x minus 4. Well, right off the gate, we should notice that these are actually the same, but we can go through and algebraically show that. So we can say 2x minus 4 is equal to 2x minus 4. So we can add 4 to both sides. And then we get 2x is equal to 2x. And then we can subtract 2x from both sides. And then we get 0 is equal to 0. So here we got 0 is equal to some number, no solution. Here we get 0 is equal to 0. When will that be true? That will always be true, so we have infinite solutions. And then another example we have here that we can solve. We have 4x minus 4 is equal to 3x minus 3. So we can subtract 3x from both sides. X minus 4 is equal to -3. Add 4. Add 4. And then we get x is equal to 1. So here we get x is equal to 1. If we get a variable is equal to some constant, that means that we're going to have one solution. So we can see that there's 3 different solutions algebraically. You can have a constant equal to some different constant. That would never happen, so there's no solution. We could have a constant equal to the same constant. That will always be true. 0 will always equal 0. 1 will always equal 1. So in that case, we have infinite solutions. If we have a variable is equal to a constant, that will happen only when the variable is equal to that constant, so that will just be one solution. And then the last thing we can take a look at is if we look at these equations, what do we notice about the slopes and things like that? So this first one, what do you notice about the slope? In this case, the slope for both of these is the same. And the y-intercept for both of these is different. One's -4 and one's +3. And then what do you notice about the slope for the infinite solutions? They're the same. And y-intercept, those are also the same. They're both -4 because they're the same line. And then the last one, we look at that one, we have our slope for this one is 4 and our slope for this one is 3. So those are going to be different. And for -4 and -3, those are also different for the y-intercept.